Welcome to Data Myths Podcast with your hosts, Brian and Malinda Gagnon. Today's episode, we're going to talk all things autonomous vehicles. We're going to talk about everything from the tech to the legal to the financial pieces and where we're going next in this lovely world we live. You ready? Well, let's dive in. Good morning, Malinda. How are you doing today?
Wonderful. Good morning.
Nice. So today I thought maybe let's talk a little bit about autonomous vehicles. We see it so much in the news. Not a day goes by where my news feed doesn't have autonomous this and that. And we saw no less than one whole hall's worth of autonomous vehicles at CES. So let me ask you the question. Are you ready to run out and buy an autonomous vehicle?
I am. Yeah. But I think it's important to talk about how autonomous they are and what is expected of us as drivers to still participate in this autonomous driving experience. So I think that's really where the debate is right now.
Nice. Well, and I will say you used the Tesla Model X. What was that? Probably 3 years ago.
Yeah. It was awesome.
I was in the back seat. I was not feeling so awesome when you floored it, and we flew on to the 101.
Yeah. A little backstory. So while I love driving, I don't love driving when I'm traveling most of the time because it's just kind of another thing to have to do. So while I've been to California a lot, I'm either in an Uber, in a cab, on the trolley, whatever, but not driving. So yeah, that was my first time driving on the California freeway, testing autopilot in a Tesla. So that was an experience.
Nice. And what was your takeaway from that? I know that was fairly early, and that's not quite autonomous driving. It's semi autonomous. Can you maybe
Right.
let's back up a little bit. Why don't you take a few minutes and tell us? I know you've got a lot of experience in looking at this industry. Take us on the journey a little bit of what autonomous means for an
Sure.
automobile.
So essentially with that Tesla example, that was autopilot. So what it did was able to simultaneously accelerate, decelerate, and steer, right? You had to always pay attention. So if the car sensed that your hands weren't on the wheel for a certain amount of time, it would, kind of shake.
Okay, so basically, kind of like plain autopilot. So it basically was guided by the human.
Exactly. So with autopilot, and with any capability of these autonomous vehicles, as the driver, you've got to understand, okay, what's my role in this car, right? So with autopilot in that Tesla, my role was to pay attention 100% of the time, even though the car was amazing. So once I was on the freeway, hit autopilot, going 60 miles an hour, packed freeway, I never had the chance to be nervous, meaning the car responded before I could have the thought of, oh man, I hope this thing slows down, or oh wow, I might be, veering in the lane. Never had the chance to worry. The car took care of it.
It's the best driving I've seen you do.
Thank you. It was really incredible. I mean, I was absolutely impressed. Not only is that car designed just beautifully, it functions amazing. So yeah, I'm a huge fan.
Nice.
Now, to put it in context, that is a level 2 of an autonomous functionality.
So describe to us the level. I don't know the levels, so take me through it.
So
I love levels.
yeah, it's like trying to make sense out of this. So essentially, there are 5 levels that help us to understand how autonomous a vehicle is. And
Is it like horse-drawn carriage to like Jetson mobile? Is that sort of
The horse-drawn carriage actually would probably be a level 2.
Nice.
It's kind of like autopilot. You have to pay attention, but the horse is doing a really good job about noticing the environment and accelerating and decelerating and steering around things. So, yeah, the horse-drawn carriage is a lot smarter than a lot of our vehicles, for
All
sure.
right.
Hmm.
Cool.
So essentially, level 0 is there's no automation. So, you know, and when we think about, well, what is automation? It's essentially automating the dynamic driving tasks, right?
So I drove a Ryder truck with my boss's stuff once when I was 22, right out of college, across the country. I had some autonomous driving because it took so much effort to keep the pedal down to stay at 65. I stopped at I think it was a Modell's, and I bought a hockey stick that I cut with my Leatherman to jam between the seat and the pedal. I probably was that autonomous.
It was a level 1. Yes. So 0 is nothing. Level 1 is you have either steering or acceleration and braking control. So
Is our car,
you
what's our car? So our car has auto following, auto braking, and when somebody cuts
so
out in
that's
front
a
of you.
level 1. And
Okay.
actually with your U-Haul example, you were just like setting the speed and that was it, right?
Yeah, and then
Y- y-
I was paying attention
Okay.
the whole time, I swear.
So that's actually, sorry, that's a level 0 because it doesn't adapt. It's just
Oh
straight
no.
up cruise control.
It was binary.
Yeah, yeah.
It
So
was
that's
on or
that's
off.
sorry, that's actually a 0. So yeah, adaptive cruise control is a level 1. So it can accelerate, decelerate. It's learning its environment. Level 1 is either or, so it's either steering or accelerating, braking. So level 2 is this partial automation, this autopilot, right? So
Okay.
so it
So
can do steering and acceleration, deceleration.
so let's so the plane industry or the avionics industry has been automated for quite a long time. Autopilot has been along since I'm guessing the late 70s, maybe early 80s, maybe a little bit later. Uh, so they really haven't advanced that much in some cases because that autonomous functionality is not there, meaning the plane can land, it can do all those things, but somebody still has to look out the window to say, oh goodness, there's a plane crossing the taxiway onto my runway. Boy, the plane's coming in on the nice glide slope and all of that. And it's going to land itself, but it's going to land itself right into the side of something that it shouldn't. So
Right.
that,
Yeah, and
yeah.
that's why you still need to have a pilot, have a driver that is 100% paying attention and ready to jump in. So the next level that is dangerous is this level 3 because it's more advanced than autopilot, but it's still not truly autonomous. So the driver can start to really not pay attention, but the vehicle isn't advanced enough to really be able to drive on its own. And to give an example of how some manufacturers are handling this, they're saying like, hey, look, we're not messing around with level 3 because to get all of that more advanced functionality, we're still having to invest in all of the sensors,
So
in radar, lidar, all of these, more advanced features, and we might as well just go the extra mile and make it a level 4, which is actually an autonomous vehicle with some limitations still.
So this is like where Elon puts the autopilot on and actually leaves the front seat to go back and dig through his bag to get the rolling papers.
Yeah, he could do that with a level 3, but it's dangerous.
Excellent.
Yeah.
Nice.
So, um, so yeah, I mean, and essentially, that's that's that kind of dangerous area of the car can do a lot, but you still need to be 100% paying attention. And level 4 is really where the car is driving itself. The limitation is that it has to know its environment, meaning there's a map that the car already knows. So it's operating in this known environment. So that's why, for example, Waymo, so Alphabet's autonomous car, is being launched in the Phoenix area. It has a map of that area, it's its controlled environment, and that's where they're testing it. That's a level 4 autonomous vehicle.
So let's not go to the deeper depth just yet. I have a couple questions or thoughts, I guess. And one of those is obviously we've seen in the news, specific to Uber driving car. I think someone died in a car with them that was autonomous. I also think a couple people have died in their Tesla, mostly in California, where one ran into a truck, one ran into a
Yeah.
barrier.
And that's where the driver just didn't react. And you know why that is, it could be the car was doing awesome and they thought the car was going to react, and it's just not quite to that level yet.
Well, and I think of, I've been on a number of trains at airports all around the world that have, the trolley that takes you between terminals. I haven't seen a person driving one of those in the last at least 10 years that I can think of. I've been to Vancouver, that train system, fully autonomous. And then you read in the news train crashes all over the place where, the operator missed the signal or overrode the signal, whatever. Same with plane crashes. That Air Korea crash in San Francisco, where they had auto brakes or auto throttle on, and they were kind of looking out the window, thinking about getting some a nice boule at the airport and maybe some Ghirardelli chocolate, and flew it into the seawall.
Well, and that's the challenge of the pilot and the driver right now, or the engineer of the train, is you have to stay alert, even though there's so many things either doing your job for you or helping you with your job. And I mean, we all can put ourselves in these people's shoes. How alert would you be when 90% of the time, and I'm just guessing if it's at 90%, maybe it's 80%, that everything's going just fine? It's a challenge to just keep yourself on your toes.
Well, and so the interesting part to me is when we look and dissect that scenario we just talked about, right? The train that uh, has some automation, or the plane that has some automation, yet we're still making human error that is causing life and death situation. I mean, it's rampant in both the airline industry and the train transportation business. Now we're getting into what people think are autonomous. It's not truly autonomous because there's still a driver attached, and the driver is, in most cases, making a mistake, or we fail to miss the part that 40,000 people die every year, give or take, in driving their own cars. And we're talking two or three that have died at the hands of a computer.
Right. And I think that's the danger in marketing these days and tech hype. I'm a marketer. I understand that industry and understand with how you need to connect with consumers and generate buzz and all of that. The dangerous part of how a lot of this is talked about now is that it's really not accurate to describe what we have on the roads today. I mean, unless it's truly some of these test cases like Waymo and Phoenix, right? But if you're a level 3, you're not an autonomous vehicle. So it's you still need the human, and the human has to be alert, and they have to have their hands on the wheel and their foot near the brake. That's what is expected of that driver to be safe. So, while of course I think when anyone buys their Tesla, the dealer will tell you that, but there still needs to, I think, be this just acknowledgement that that's the capability, and it's awesome. It helps a lot. I mean, our Jeep has adaptive cruise control. In the scheme of things, that is really not that innovative, but it makes my life so much better. I love it.
But you have also, because I've been with you and I've done it too. We've gotten behind someone just poking along for a nice Sunday drive, and then you realize our nice, adaptive cruise control slowed down and followed that people while everybody else is passing us, right?
Oh, yeah, exactly. If I had been operating it myself, I would have said, wow, I'm now going really slow. Or I wouldn't even have gone slow. I just would have passed.
I don't think slow is in your vocabulary.
No, that's probably why I don't like driving on work trips in traffic. But so so that brings us to, the highest level, right, that we have now. So it's either 5 levels. So level 5 is an autonomous vehicle that can operate in any environment. So, the level 4 needs a map, a 3D map. Level 5 won't need that. It will be intelligent enough through all of its sensors that it can navigate. And, that is the vision, right, for where we're headed in the future.
So let's talk sensor importance for a moment, right? So back to the airline industry, last couple planes, and not to talk tragedy, but let's say the airline, I think it was Malaysia Airlines or Lion, actually it was Lion Airlines, brand new 737 Max. All kinds of capabilities, all kinds of automation and safety components, a pitot tube or something like that that senses either angle of attack or wind, airspeed, had a bit of a failure, and then actually, kind of caused the pilots to react in a poor way. As we get to more autonomous cars, these sensors are going to be really, really critical, right? Whether it be plugged with snow, or, the LiDAR gets reflected off of fog, you name it.
Do you want to explain what LiDAR is?
Yeah, no, I'd love to talk about lasers. Yeah, so I mean, basically, when we were at CES, it was really interesting to me because the component makers were there in full force, right? They were talking about all things LiDAR and different types of multi mode LiDAR mixed with radar sensors, mixed with forward looking infrared, and it's really kind of that combining and putting all of those sensors together to sort of come up with the best output. But when you think about that, now you just 3x or even 2x the amount of sensors and data and compute that you have, that you're expecting a car that previously had a computer the size of you know half a loaf of bread. How are we going to fit storage, compute, and all of the power involved with this, right?
And do you think it's the best way to think about the technologies needed in these autonomous vehicles, to think of it in terms of camera based, radar based, and then do we want to call it data based? So the maps that it's referencing, the all the information that it's learning over time.
Well, I tell you what, if you've ever driven in Boston, right, I do not want to base my life on making sure the map's updated because, I swear sometimes the roads move overnight.
Yeah,
So, I,
we
I
need level 5
yeah,
to
no,
be in Boston.
I'm pretty good with that. And the other piece to that, right, is it's not just autonomous vehicle inside of the vehicle, it's also the mesh, right? It's the network of vehicles, and vehicles being able to send information to other vehicles, much like AIS in the container shipping or just shipping industry. AIS came about to show things like ship velocity, ship direction, rate of change, etc., to really help prevent collisions at sea. And that's really just starting. That's got a couple, maybe 10 years under it, or better. It's starting to get into the public space, but that's actually done wonders. As we look at cars, if the car ahead could tell you, hey, I'm slowing down, or my rate of change, or even the map or the destination that I'm going to is about to change, now the system can start to be a lot more intelligent in predictive analytics, really, and what's going on, you know?
Yeah, absolutely. I mean, think about how good the traffic report's going to be when every car is reporting what's going on every moment.
So we've talked a little bit about sensors. I'm not going to go too deep into LiDAR. People can look that up. Really, it's just, you know, radar.
Bouncing lasers off things.
Yeah. And getting, millimeter or better accuracy on locational, things, or speed.
Do we want to talk about leaders and losers for a minute?
I always love to talk about leaders and losers.
Okay.
We should make a section of this podcast called Leaders and Losers.
Perfect.
Perfect.
It's great.
But let's I want to talk a little bit more about kind of the what's needed to sort of get to that level 5. And I know
Mm.
there's a ton of tech companies, they're all scrambling to get there, to fix sensor problems, to fix compute problems. I know Intel, Nvidia, you name it, Tesla's got their own chipsets that they're working on, to really solve the compute involved with this much data. And you said maps. I think of, the maps of old where you've got a DVD and 4 or 5 gigs worth of map data that has to get updated every so often, that sits in the trunk of the car, that makes your GPS up on the dash work. We're talking a whole lot more data, because it needs to change a lot quicker. So now we've got a storage problem, right? So I just read an article this morning about how autonomous cars aren't going to be a reality until 5G gets here. I disagree with that in a way, because I think we have to get a lot smarter about what is stored locally in the vehicle, at the edge, and what is sort of stored off in the cloud, so that decisions can be made rapidly. I mean, that's a big gap.
Absolutely. Yeah. And when you say the edge, tell us, want to define some of these things along the way. What do you mean by the edge?
Well, I'm not talking about the U2, guitarist.
Ooh, it's amazing.
Yeah, no, totally.
And my idol.
Yeah, he's not my idol, but good for him.
Mm-hmm.
Yeah, so the edge is really where an IoT sensor or device or network node, um, it's the edge. It's like where the data and the action is really happening and coming from, right? Then we obviously have the cloud and the network of, thinking, doing. And so one of the challenges with this, right, is when we look at data science, when we look at machine learning and neural networks, it is, and when we take away the map, right, we cannot create, or it is very difficult to create, um, instruction sets for all of the things that you would encounter with the automobile so that you can get rid of the map. So now we have to create a vehicle that can process wide sets of data so that it can make a deterministic outcome. And that takes a ton of compute. It also takes a ton of different, scenarios and situations and data. So that's a challenge.
Absolutely. And when you think about the level of information that's going to be needed and the machine learning that's going to be needed to navigate in these changing environments, it's going to be quite a haul to get there. MIT Media Lab did a really interesting study a couple years ago, and it was around asking this question of how would people prefer a machine to make a decision when, for example, and this is what the whole study was around, you're in a car and the collision is inevitable. Like you're going to crash into something. So, how do you decide what to crash into? Do you crash into the car in front of you? Do you veer off the sidewalk and clip, this one elderly man? Do you go across the highway and potentially veer into the farmer's market?
So I think they call that the trolley effect, if I'm not mistaken.
Well, it was really pretty fascinating. This is one of the largest studies that have been done around this. They call it the moral machine. And over 2 years, over 2 million people participated across 200 countries. And what was really interesting is different areas of the world, different cultures actually made different moral decisions. You could say overall that, of course, like people generally decided, okay, if I have to hit something, I'm going to go one person versus a group. That was consistent. But there were some areas of the world that would spare the fit person and hit the overweight person. There were other cultures that would rather hit the young person versus the elderly person. And it started to bring up some pretty interesting parallels with cultural values and how people make decisions. So, you know, our last episode was around AI bias, right? So, is that what we want to do in our level 5 autonomous vehicles, to say, oh, this vehicle is going to be released in Southeast Asia, let me apply my moral, algorithms and learning to what these people would typically do if they were driving the car versus the machine driving the car.
Yeah. I mean, that's interesting. Here's another thing to think about though, right? Like, so what about it's not people owning the car now, right? The model is they're talking about changing the model and this being a $7 trillion industry over the next 20 years. Uh, and we're not even owning a car anymore,
Yeah,
right? So now you and I might make a different moral decision than Uber.
right.
Uber might base this off of legal precedent, right? Or legal responsibility, right? So now legal starts driving the AI engine. Is that good or bad? I don't know.
Well, and you could fast forward to an ideal future state where the only vehicles are on the road are autonomous. And at that point, hopefully they're working together in known environments. So, you know, the level of crashing is reduced. While we have a hybrid environment, it's going to be pretty interesting to see. And, when we think about that future state, it's really like the mobility fleet, right? I mean, this is trains, planes, automobiles, scooters, and drones, right? Eventually, of how is that all coordinated in a way that moves people around, right? It's not just cars, obviously. It's trains, it's subways, it's again, like if you can't get someplace with the car, maybe it's quicker to pick up, the rental scooter or whatever it is and shoot across, midtown on that versus get into the autonomous car versus get on the metro, right? So once we have that level of connectivity, that will be a whole nother ball game. And then, this kind of fleet mentality will start to be a possibility.
Yeah. No, that's interesting to think about. And I do want to go back to the legal piece though, right?
Mm-hmm.
And so one of the challenges has been, and this is funny challenge, right? Who do I give the ticket to? If I'm the officer and the machine happened to be speeding or run a light or something.
Uber gets the ticket. Oh, won't they
Yeah,
love
yeah,
that?
exactly. Who gets the ticket? Well, that's a very minor incident of how that flow goes. But now, if we get into legal liability, you know, and we're thinking about, okay, do I hit this or do I hit that? Um, that's not necessarily a game that I personally would want to have to think about.
And to program, can you
Yeah,
imagine?
I mean, you are assigning value to people at that point.
Well, and that brings us into like weaponization, like when you're putting value on people. I mean, literally, think about it that way, right? Draw that parallel. With autonomous weapons, we our military says, well, a kill decision is not made autonomously.
Okay,
Well,
I've
when
got it.
you're in a vehicle, you have to decide you're going to hit something. What do you hit? Unfortunately, you can't avoid that situation sometimes. So now, obviously we're in a real ethical,
Yeah.
you know,
I mean,
mire.
that's a lot to think about, right? And because it
Mm,
does, that starts to assign value. And, if you're at the unlucky end of that, payload, so to speak, whether it be the car that, loses a tire and spins out of control and,
yeah. And watch out if you're a young person in a country that, they rather, save the elderly. You better watch yourself on the sidewalk.
yeah, you don't want to be a young, chubby,
No, don't
whatever
be
person.
exactly.
Yeah. So that's bad.
Hmm.
But yeah, so that's really something to think about, right? And these are those types of moral dilemmas that we're going to have to get to. How far is too far? And is that what machine empathy looks like? Does machine empathy have a legal team behind it?
And that's the thing. I don't think machines can have empathy. You have to train them. It's determined, right? It's not emotional. It's
So
learned.
it's interesting that we bring this up a little bit. I saw an MIT um, article about really creating that uncertainty in machine learning, and that they're wondering if that uncertainty, and if it hits uncertainty, um, it kind of stops making the decision, or it backs off from the accuracy of the decision to sort of solve some of these problems. It's almost like inserting the you know the random I feel lucky button on Google, right? Where you're like, okay, the car's going to crash. Let's just go to the random number generator and see what prize we got.
Well, that's like the good old, oh, I love to take a drive to clear my head. Well, that goes out the window with all this stuff. But yeah, if you have your let's get random button, you can have that drive to clear your head. Oh, I don't even know where I'm headed. I just like to drive. Well, okay.
Nice. So we need to make an autonomous vehicle magic 8 ball to shake in the back.
I think so.
That's perfect.
Yeah, that would be fun.
So awesome. Well, I think this has been a awesome discussion. There's so many more places that we can take this.
Yeah, and I mean, I think one point to make, is when we think about like where the industry's headed. Certainly, Alphabet with Waymo is doing incredible things. So in terms of distance that has been driven autonomously in 2017, Waymo, I mean, far outperformed other companies. So 352,000 miles. So GM Cruise was at 131,000, and everybody else was not even hitting over hardly 6,000. So there, that's pretty interesting to see. And they've just announced that they're investing in a new production facility in Michigan. And Jaguar and Chrysler are going to be the actual vehicles that they're working in, because before that time it would all be like aftermarket, that how they would create their vehicles. So this is really that partnership. And when we think about, and this is the leaders and losers, by the way. So Waymo definitely a leader. Loser right now is Apple. So they have this Project Titan. It's been going on for, gosh, I don't know, at least
But
4 years, I
but it's
think.
going to integrate so nice with your watch and your
Yeah.
phone.
Well, yeah, they're moving people off that project. I mean, they just 200 people are going to be moving off, and it's really not moving forward in a way that's making impact. So, you know,
So
interesting to see who's emerging and who's lagging.
so on this topic, right? When you back up to 1895, when Maybach and Daimler and companies started to really build out the car, and Ford came on the scene, started to build out the car. Uh, it's really interesting. It took almost 20 years to put 1 million cars in production. Electric only vehicles, I think in 2010 or so 8 years, we've gotten to about 1 million vehicles last year, give or take. There's different studies out there. So that's moving quite a bit faster. I feel like autonomous driving cars is moving even faster than that. And I think, to kind of get to that point, it feels like it's going to be here a lot quicker than anybody has expected.
Yeah, I mean, and you mentioned earlier about the fact that there are like 40,000, was it fatalities a year with car
Yeah.
crashes, and there have only been like you know enough to count on one hand with autonomous vehicles. So over time, the public will come to trust this more, and the functionality is
Well, will
getting
they?
so much more advanced.
Will people come to demand it? Is my
Yeah,
question. I
I
mean,
think
they're
so.
they're doing it with trains now, right? Everybody's talking about the devices that they put on trains, and they're demanding it, right? And Amtrak's not getting there that fast. I mean, it feels like they're speeding it up, but there's still been quite a few bad crashes. And so to back up where I was going with, the 20 years to 1 million, right? Over that time period, there were over 125 car manufacturers from like 1905 to 1920 or so. And then a few years later, there were 20. I think that there's a lot of people with their hands in the pie here. And I think there are going to be a lot of first losers. And there's going to be some last losers in some industries too, meaning the traditional car market. There are going to be companies that don't make the leap or don't make the leap far enough. What are your thoughts on that? I think it's coming, right?
Yeah, and it's changing the whole economic model too around the industry. So, if we think about the value of a car, right? And with a car with no automation, you have the feature set you have. It depreciates over time. And maybe in, 5 years, 3 years, you go and get a new car because it's outdated, it's getting worn down. Okay. So these autonomous vehicles, you still, of course, have your just hard costs, but the real value is in the software. So in climates where you don't have, salt on the roads like we do up here in the Northeast, or other weather conditions that just break down the integrity of the vehicle, does that model switch to just upgrading software, after those, maybe a year or even two, versus going out and buying a new car? So how is this going to change the industry in terms of, how much these auto manufacturers are actually making?
Well, then that's an interesting concept because two things happen. One, that makes you tremendously reliant on these car companies. And let's face it, there's a lot of rumblings right now that with Elon Musk's, edict from the other day that Tesla's in trouble, and what happens if Tesla goes away? Who takes over those software updates? If some of these companies either go out of business, decide to go in a different way, does your car become useless? Does it? What happens?
Well, maybe that's a whole nother industry that we haven't seen yet that could be akin to, your extended warranty or your insurance. There are companies that you can hire to overlook, I don't want to say overlook, oversee your software, right? So that could be a whole nother area of service that just isn't needed now, but it could be in the future.
That Yeah, that's an interesting concept because there's a ton of independent as well as franchise based auto repair places today that doesn't really exist in the Tesla model specifically. So what does that look like?
Right.
The other piece to that is, as we start to look at that, do you have to own a car?
Yeah, great point.
You know,
And the shared service, does that become more common and more advantageous as people, start to more and more prefer the urban environment? And And in urban environments, of course, that's going to be the first place that we're going to see autonomous vehicles because it's the known environment, right? That's that good old level four we've been talking about. So, yeah, maybe that autonomous vehicle ride sharing, is going to become more and more popular. And that's Waymo 1 is essentially the test of that, that's happening right now.
So I guess the big question, and so we see the network providers being Lyft and Uber and whoever else, and then we have the supply side companies, the manufacturers, Ford. I would even maybe put Waymo in there, right? Volvo, a number of the other ones, Volkswagen. Um, and so I see that, and traditionally the manufacturers have sold to customers, end user customers or major transportation systems. The other side has been creating demand and servicing that demand with a sea of vehicles that they don't own, right? Is there a third way, which is fractional ownership, where I buy my car, I want to make a capital investment, and it's an investment at that point, and maybe the thing costs $100,000. It sits in my driveway, and I put in. It looks at my calendar, my schedule of things, and it knows that I'm not going to be using it probably realistically for the next 4 hours. Does it go out and get a job, right? And go out and start picking people up off of the Uber network.
Right, right. And, and that's what, Turo is, right? Like
Yeah.
you can sign your car up for that shared economy kind of thing, which would make me super nervous
Yeah, but
personally, but I guess people do it.
I mean, people do it with their airplanes today.
Right,
I mean,
right.
the majority of airplanes, private airplanes in the United States, are owned by more than one person,
Yeah.
right?
And they say they have 4,500 cities, 300 plus airports. So I mean, yeah, this isn't like a small endeavor here.
Yeah. And so when you think about it that way, right, now you have a different way of monetizing it. Is that the gateway drug that gets people to give up their traditionally non autonomous car that they own? Do we make it so that they can monetize that piece of machinery?
Well, and I think that tipping point will happen when the factors of convenience and safety dictate that. So people want to have their own cars for those two things. It's convenient, it's safe, right? If if those two things can be accomplished with this shared fleet, then yeah, why would you want to pay for and care for your own car?
Well, and it's economics too, right? I mean,
Absolutely.
it's, to own a car in the city specifically, you're talking 400 or 500 bucks a month for a parking spot. You're talking, you know, at least double the insurance cost. You're talking a whole bunch of things,
And
right?
having lived in Boston for almost 10 years and not having a car because I didn't want to deal with moving it when, we had parking bans because of snowstorms and horrible on street parking options. You drive around the block 45 minutes to find a spot. Imagine how easy breezy that city would be to have all of the cars parked in a designated lot in a fleet that were just moving around the city and going to park where they needed to park when they weren't in use.
Well, that brings up another interesting concept. What about having government or, municipal overrides, right? So in a situation like that, a different way of thinking about it would be, what about if you owning the car, it knows where you live, and they could send out like a, emergency broadcast alert that your vehicle has to move, and your car just moves, right?
I don't,
Do we want that
I,
level of autonomy? I don't know.
yeah, I think that would make people pretty upset. But it could be pretty convenient when you don't want to go out into the snowstorm and move your car. But I don't know. But like to think a little bit more about the economic implications when you think about what like this whole concept of mobility, in whatever form it is, whether it's, you know, taxis, your personal cars, whatever. So that's more than a $2 trillion industry when you think about the actual vehicles, insurance, fuel, medical, legal. I mean, everything that touches it. So the ripples that it's going to have is incredibly significant. And of course, the biggest share of that pie is the actual, vehicle sales, service, supplies, and the people who fix the cars. I mean, that's there's a stat from, these are 2014 numbers I'm looking at right now, but 735 billion in that category.
And that was like 4 years ago, 5 years
Yeah.
ago almost.
And the second highest, 573 billion, is oil and gas.
Wow. Well, my question is, insurance companies have been, you know, making money off of this because they price it in, right? What does this do to their revenues? Because now all of a sudden, where there's no risk, there's also probably no margin. I guess it's more predictable for them, so they can have a more predictable outcome. But more predictable outcomes rarely mean that you make more profit.
Or does it become the case when there is a mistake, it's the mistake of the technology, and now you're going after Alphabet when something actually goes sideways? And granted, the instances of that are fewer and far between, but what they would get for that is obviously much more significant than a typical auto accident.
Well, and it shifts, right? So the risk of the fender bender probably drops off, precipitously, because I feel like that's a pretty easy thing to cure for if the rate of crashes comes way down and that risk model comes way down. Investors that invest in an insurance company are going to be a heck of a lot less willing to pay a premium on that because the risk is so easily modeled,
Yeah.
right?
Yeah, absolutely.
You know,
So yeah, I mean, there in any space where we see such upheaval. I mean, I worked in well, for a huge healthcare conglomerate when Massachusetts was going through, their universal healthcare, and the fact of, you know, how it was fundamentally changing, of course, not only, hospitals, insurance executives, lobbyists, everybody who had to come to the table because it had such far reaching implications. This is even bigger. It uh, just affects so many different industries. So you're going to have a lot of different players who are advocating for a either smaller or more gradual growth rate and rate of change because it is so potentially damaging to their businesses.
really, yeah. I mean, there's a lot to think about with this, and I go back to the storage industry. I spent a bit of time in that. I'm not a hardware guy, I'm a software guy. They were getting all excited about, petabytes. They're estimating that, the average autonomous vehicle is going to need about 2 petabytes of data to be able to make its decisions. That's a lot. That's a lot of data. I mean, that's a pretty good, revenue run rate. And then when you think about the compute to be able to do that, cars aren't built for that. They're not a mobile data center today. I know that that's coming. I know that that stuff is well on its way, but I think, that it's really interesting because this is growing so fast. I think what happens is anytime an industry is moving at this velocity, you look at Microsoft Windows and operating systems, Moore's law would kick in where they would every 18 months stuff was getting faster and the hardware was getting faster. Well, the software got to be pretty lazy. Well, when you start to reach that, the top of the curve where hardware advancement and such and system advancement starts to kind of plateau off, now all of a sudden you have to start getting really precise with what exactly, what is the value of this data again? You know, do I really need to have 2 petabytes, or am I able to have a few more guided decisions in there that take up a whole lot less space, and maybe I don't need all this data? You know, we're coming up on the top of top of the hour here. So let's kind of close this out. I mean, there's so many more places that we can take this and compare it to other industries. What do you want to say in closing, Melinda?
That I think it's important to be just eyes wide open around the partnership right now between the machine and the human. That's what's, we're able to take advantage of these really great new features. We still have to be involved, and yeah, it's exciting to see what Waymo's going to keep doing, and Tesla, and excited to see how it evolves.
Nice. Yeah, my thinking on this is that the places that I'm most interested in, how do we, make that edge much more efficient than it is today? That's going to be key, because I think the answer of we need just a ton of storage and a ton of compute and 5G or 6G or whatever else, I don't think that answer plays out for very long, because if an automobile can't operate by itself without a network, um, I think that's going to be a challenge, right? Because at some point that cord gets accidentally cut. We don't want everything ceasing to a halt. The other piece, and my big takeaway from this discussion, is really getting to that moral ground and that legal ground. How do we bridge that gap? That is going to be, in my opinion, with machine learning and AI, we keep coming back to that, right? Which is, that is such a huge problem to solve. How do we put value on people's lives? Who makes that decision? All of those types of questions, when we start to get to that, that is such an ethical boundary that I don't know how we're going to cross that just yet.
Yeah, I mean, so far Germany's tried to set some rules around that. They said that if there's an unavoidable accident, you cannot make any distinction on personal features. It's prohibited. Age, gender, physical, mental condition. They're trying to say that, but how, you know, it's of course great in theory, but yeah, how does it actually play out? And
I just want to
see,
keep going on this topic
there's
like
a lot to go on,
all
but
day. I know we're coming up to 55 minutes. That's the number I get like weary around, but let's wrap this up, and,
yes,
and we'll close it out. But thank you everybody for listening. Thank you Infonomic Data for sponsoring us to put this podcast on. We have a lot of fun with this. It's always fun on Sundays are usually kind of our days to record a bunch of these. And thank you to all of you for listening on and hopefully making it to this point. Next week, we'll have a couple new great topics that kind of expand on this. And thank you, Malinda, for taking the time to do this. I know you're super busy, and let's have a great week.
great stuff. Thanks so much, Brian. Thanks, everybody.